So here we are given a sequence. They say, consider this sequence. And as I told you, the word consider means you carefully look at what you're given and you make sense out of it. And now that it makes sense to you, then you're going to answer the questions. So the sequence here, we have 2, 3, 5, 6, 8, 12, and it goes on all the way to infinity. And here they say determine the next two terms. Well, if we can look at this sequence, it really doesn't make sense. Because here you have a constant difference of 1, but suddenly it's now 2, and it's 1 again. It's now 3, and it's now 4. Imagine. So it really doesn't make sense. But then as you are busy trying to look at it, thinking about it, then suddenly you realize that it's actually composed of two sequences. It's two sequences that are being added together, or rather combined. Yeah, combined is a better term than added together. What do I mean added together? Combined is the right term. What is the first sequence? That's 2, 5, 8. When you isolate this, now you see very much clearly that this is a linear pattern, which is having a constant difference of 3. Now, what about the other one? Well, here we have 3, we have 6, and we have 12. And if you give it a good look once again, you see that it's actually a geometric sequence that has a constant ratio of 2. In order to get 6, you had to multiply 3 by 2. In order to get 12, you had to multiply 6 by 2. Which means in order to get term number 4, you have to multiply 12 by 2 as well. But then here, in order for you to get term number 4, you just need to add 3 to this 8. So then it stands to reason to say that the next two terms here will simply be 11 as well as 24. Yes, those are the next two terms. Well then, moving on, they say we need to determine the sum of the first 39 terms of this sequence. And this one is really important. The way it's so important, it's very important. Now let's talk. Here we can see that we have terms that are alternating, right? The first term is an arithmetic sequence, is in an arithmetic sequence, in fact. But the second term is in a geometric sequence. The third term, arithmetic. Fourth, geometric. Fifth, arithmetic. Sixth, geometric. Where am I going with this? This is what I want you to realize. If the question had said the sum of the first 5 terms, I want you to realize that the first 5 terms would actually be composed of 3 for arithmetic and 2 for geometric. Do you see what I'm saying to you? Because they are alternating. It's not equal terms. At any time of day, or rather, for every odd number of terms, 39, 37, 35, the arithmetic sequence will always have more terms compared to the geometric sequence. In 5 terms, we have 3 for arithmetic and 2 for geometric. which means in 10 terms, we have 6 for arithmetic and 4 for geometric, which means in 39 terms, we actually have how much? Or maybe we should begin at 40. In 40 terms, we actually have 21 for arithmetic and 19 for geometric in 40 terms. What about in 39? We actually have 20 terms for what? For arithmetic and 39. 39. Yes, 19 for this one of geometric. 21 plus 19, is it really 40? Of course it's 40. So yes, that's what I'm saying to you. They're not evenly spaced. The arithmetic will always exceed the geometric by 1, as long as you are dealing with an odd number of terms. Well, I spoke a little bit of a lie to you when I said in 10 terms, you'll be having 6 for arithmetic and 4 for geometric. No, that's actually a lie. If you have an even number of terms, then your number of terms will be equal. You'll be having 5 for arithmetic and 5 for geometric. If it was 40, then you're going to have 20 for arithmetic and 20 for geometric. But if you have an odd number, like in 19 terms, 10 will be arithmetic and 9 will be geometric. So in 39, 20 is arithmetic and 19 is geometric. So in any odd number of terms, the number of terms in an arithmetic sequence will exceed the number of terms in geometric sequence by 1. Yes, I'm sorry for saying that. I didn't really give it much of a thought before I said it. So please forgive me. Okay, so knowing what we know, then it's time for us to find the sum. And here we understand perfectly that we need to consider 2 series. Okay. Well, let's consider the first one, which is 258. So we have 258, and this goes on all the way to infinity. That's fine. But then for this one, we know that we actually need to find the sum of 20 terms because it is arithmetic. But then the marker doesn't really know that this is an arithmetic sequence. So we have to convince the marker. How do we convince them? Well, by taking term number 2 and subtracting term number 1 from it. So we say, well, we have 5 minus 2 there, which is 3. Then we take term number 3 and say, let's subtract term number 2 from it. And we also get a 3. So now we can conclude that the constant difference is 3. Because honestly, we were not given that this is the sum of arithmetic and geometric. It wasn't explicitly stated. So we have to show them that we actually understand that it's arithmetic and geometric. And we also do the same for the other pattern, 3, 6, 12, going on all the way to infinity. So here we say term number 2 divided by term number 1. Well, that's 6 divided by 3, and we get a 2. Term number 3 divided by term number 2. That's 12 divided by 6, and we get a 2 as well. And now the conclusion is the constant ratio is simply 2. Well, A is the same for both of them, but that's fine. Then now we come back for this one and find the sum of 20 terms. We don't know the last term, so we'll just say it's 20 divided by 2. And then we say, well, we have 2 into A, which is 2, plus n minus 1. So we have this, and then we times it by the constant difference. And when we go to our calculator and say 10 into 4 plus 3 into 19, well, we simply get 610. Then we come back to the other one and we find the sum of 19 terms. And this will be given by the first term. Did I say A is the same for both of them? What is wrong with me? Well, for this one, A is actually 3. Sorry about that. And then you say, well, our A is 3 here, and our constant ratio is 2. And this is raised to the number of terms, which is 19. And then we say minus 1. I'm stingy with space. I do have space down there. I'm just not sure why I choose to compress everything. Right. A is 3. R is 2. The number of terms is 19. Yes, this is what we have. And everything is divided by constant ratio minus 1. And if we now go to our calculator and determine the sum, well, we find that this sum will actually be 157. Well, it's actually a million. So it's 1,572,861. Then we can now say, well, therefore, the sum of 39 terms is just going to be the sum of 20 terms for this and the sum of 19 terms for that. And if you add them together, you simply get 1,573,471. So yes, that is how you would find this sum. Well, the next question says we need to write this series in sigma notation. So we have 64 over 5 minus 32 over 5 plus 16 over 5 minus 8 over 5. And this goes on all the way to a certain number of terms. Well, it's actually going to infinity, but yes, that's what they say to us. Well, firstly, we need to determine what type of a series are we dealing with. Because in order to find the sum to write a series in sigma notation, we just need to know the general term as well as the number of terms. Well, we can't determine the number of terms because they said it's to n terms. So the best we can do is to find the general term. So, well, the sequence here is 64 over 5 minus 32 over 5. 32, come on. That was an easy one. And then we have 16 over 5 and 8 over 5. And this goes on. Well, the question is this an arithmetic sequence or is it a geometric sequence? Well, if you try to find the constant difference, you're going to fail dismally. But then let's see if we can find the constant ratio because it's not given to us. So we really need to convince them. So if you take term number 2 and you divide it by term number 1, what is it going to be? Well, it's negative 32 over 5 divided by 64 over 5. Well, let's just write it like this. So, well, if we divide those two, you simply get a half, which is negative. Then you come back and take term number 3 and you divide it by term number 2. So you say, well, 16 over 5 divided by negative 32 over 5. So let's see how much do you get. Well, you simply get a negative half once again. So now you have proven beyond reasonable doubt that your constant ratio will be negative half. Well, of course, you'll write this somewhere here, but due to space, I'm just going to write it there. And of course, we know that A, which is the first term, is 64 over 5. So this means our general term will be A times the constant ratio, and this is raised to the n minus 1. Okay. Now we want to write this in sigma notation where it becomes easy. We know the general term. So we tell them that we are finding the sum of this sequence from maybe k equals 1 to k equals n. And now we need to write this in terms of k to show that the first value that we are substituting is k equals 1. And the last value that we are substituting is k equals n. So yes, that is your series in sigma notation. You just need to know the general term as well as the number of terms, and it's over and out. So the last question says to us, the numbers 7x and y, they form a geometric sequence. If the sum of these three numbers is negative 2x minus 7, determine the possible value or values of x and y. Okay, so we are given three numbers which form a geometric sequence, and we are also given their sum. Well, that's fine. So we can actually begin with the most obvious thing, which is to find the sum. So the terms that we are given here are 7x and y, right? So if we add them, if we say 7 plus x plus y, the sum of these three numbers is negative 2x minus 7. Yes. Well, what can we do with this? We can try to collect the like terms and get the x's together. Or maybe we can make y the subject of the formula because we only have one equation that has two unknowns. And we know that every time we have two unknowns in one equation, that is a call for simultaneous equations. Well, we take this x to the right, it becomes negative. So we get negative 3x. We take the 7 to the right, it becomes negative as well. So we get negative 14. And we can call this the first equation, really. But then we remember something important. They said to us, these three terms, they form a geometric sequence. And one thing we know about a geometric sequence is the fact that it has a constant ratio, which means that if you take term number 2, you divide it by term number 1, you'll get exactly the same thing as when you take term number what? Yeah, that's a good question. Term number 3, and you divide it by term number 2. Yes. And here, when you cross multiply, you find that 7y will be equal to x squared. You can call this the second equation. That's awesome because we want to prevent fractions. But if you don't mind working with fractions, you can make y the subject. But I strongly mind, so I'm just going to keep it like that. Then we substitute this equation into that equation, which means that every time I see y in the second equation, I'm just going to substitute negative 3x minus 14, and I set this equal to x squared. Then I collect the like terms, and I take them to the right-hand side. So 7 by 3, that's 21. It's negative 21x on the left-hand side, but positive 21x when it gets to the right-hand side. And 7 times 14, it's negative 98, which becomes positive 98 when it gets to the right-hand side. And now I can see that I'm dealing with a quadratic equation. And now I'm looking for factors of 98, such that if I add them or subtract them, I get 21. And when I plug this into my calculator, I actually get 7 squared times 2, which doesn't really help me that much. So which other factors of 98 can we actually find here? Well, this 49, we can actually write it as 7 by 7. So what about 14 by 7? Is it really a good combination? Well, if you say 14 plus 7, you do get 21. So it means you can choose to write this as 14 times 7. Those are the perfect factors that will give us that much. Okay, fine. So we have 7 here and we have 14, both of which have to be positive. Then you'll say, well, x will either be negative 14 or x will be negative 7. Both of them have to be negative. Very important. And then You can now safely say, well, I know the values of x. I now have to find the values of y by substitution, of course. So I know that y in terms of x is negative 3x minus 14. So I want to find the value of y when x is negative 14. So this is what I'm going to say. So we have negative 3 into negative 14. Yes, minus 14. Okay. When we find that y will be 28, and we come back again and say, what is y when x is negative 7? Well, let's see. We simply get a solid 7. Now we need to test both of these values. And how do you test them? According to their correspondence, of course. In other words, when x is negative 14 and y is positive 28, try to see that if you substitute these two values here, the left-hand side is equal to the right. It's very important. See if you get a constant ratio. Well, let's see. So here we have negative 14, okay? And here we have a 7. So we get negative 2. Well, here we have y, which is 28. And this is divided by x, negative 14. And indeed, we get that negative 2. So that combination works. Then we test another one, which is negative 7 and positive 7. So let's see. When x is negative 7, we have negative 1 on the left. And then here we say y is 7 and x is negative 7. So we have negative 1 as well. So yes, this combination works as well. So everything that we said here is equally correct.